The vulnerability storm is here, and the CISO playbook just dropped. The Cloud Security Alliance, SANS, and a who's who of security leadership. Gadi Evron, Rich Mogul, Rob T. Lee, Jen Easterly, Bruce Schneier, Chris Inglis, Heather Adkins, Katie Musuris, among others, just published an expedited strategy briefing titled The AI Vulnerability Storm. The paper's thesis is blunt. AI-driven vulnerability discovery and exploit development have compressed the disclosure to exploitation timeline beyond what current security operating models can absorb. This isn't about one model or one vendor. It's about AI materially accelerating offense while defenders haven't matched that speed operationally. The briefing introduces the concept of a Mythos-ready security program and frames VulNops, continuous, AI-augmented vulnerability operations, as a permanent organizational capability, not a project. For CISOs who need to walk into a board meeting Monday morning with a credible plan, this is the document. The timing is sharp. A stealth cybersecurity startup called Mach has released research demonstrating an agentic workflow that autonomously exploits 98% of open-source KEV's known exploited vulnerabilities using publicly available models like Opus 4.6 and GPT 5.4. The pipeline works from first principles. Given only a CVE-ID, it collects the vulnerability description and code diffs between vulnerable and patched versions, then builds a working exploit. No access to existing Poke repositories, no human in the loop. Their case study on React 2 shell is instructive. Remediation took most organizations over a week. Mach exploited it in 21 minutes. The uncomfortable implication is that Anthropic's decision to withhold Mythos may be moot. Public models already unlocked the capability that made Mythos alarming. Nathan Sportsman's Torian Guard platform demo reinforces the operational reality. Torian deploys an orchestrator agent, Marcus, that coordinates specialized subagents. Brutus for credential attacks, Augustus for LLM jailbreaking, Diana for web applications, Trajan for CI/CD pipelines, Constantine for zero-day hunting. Across every attack surface simultaneously. Constantine doesn't just find vulnerabilities. It writes the exploit, verifies it works, and can even PR a patch. During the live demo, Marcus launched 7 simultaneous attack fronts and found demonstrated vulnerabilities within minutes, automatically cutting JIRA tickets when severity thresholds were met. The platform's passive agents handle triage too. KO verified 2 true positives and 2 false positives from Wiz results without human involvement. What makes this significant isn't any single capability. It's the full-loop integration from reconnaissance through exploitation to remediation ticketing, running continuously. Meanwhile, the traditional vulnerability landscape continues grinding. Hackaday's weekly security roundup covers GDDR6. F-AIL, a Rowhammer-style attack targeting GPU VRAM that can bypass PCI bus protections. Most relevant for shared GPU hosting environments where untrusted code runs on the same card. Over 50 Android apps in the Play Store were found carrying malware targeting devices stuck on pre-2021 patches, hiding payloads inside PNG polyglot files bundled with a modified Facebook SDK. Flatpak shipped fixes for a complete sandbox escape. Minnesota called the National Guard after a ransomware attack against a county. Its second this year. Russian state actors compromised nearly 20,000 TP-Link and Microtik routers for DNS hijacking. NCCA issued an advisory on Iranian state-sponsored attacks against PLC systems, echoing the Stuxnet lineage. The S in SCADA still doesn't stand for security. Architecture beats exploit. The structural resilience argument. Brandon Levine's Vector Shift essay reframes cybersecurity with a physics metaphor that lands. The industry has treated security as a scalar problem. Magnitude without direction, measured in speed of response. But modern AI-driven threats aren't just faster, they're adaptively oriented. Autonomous agents map an environment's latent state. The high-dimensional graph of identity to entitlement mappings, service dependencies, and business logic. Then mimic legitimate administrative patterns using living off-the-land techniques. The defense, Levine argues, requires a predictive world model. A causal state engine built on normalized telemetry OCSF, mapped onto a dynamic knowledge graph that identifies functional anomalies, actions that are logically impossible within the environment's established parameters. Ephemeral architecture automated moving target defense through stateless infrastructure as code, rotating containers, session tokens, IP spaces imposes a recurring reconnaissance tax that makes sustained attack paths economically unviable. Pete Herzog, who has run ISECOM for 25 years and produced the OSSTMM methodology 3 million downloads annually, puts the same argument more bluntly. We didn't build security into the internet, so we built an economy around the consequences of not doing that, and now that economy is too big to fail gracefully. CVEs became a metric of industry activity rather than a measure of industry failure. AI didn't create the problem. It removed the last safety buffer that bad architecture was hiding behind, because human attackers had limits that AI doesn't. The solution, Herzog insists, hasn't changed. Architecture beats exploit every time in practice. Hardening, fixing architecture, and intent-based controls that make vulnerabilities not matter. 25 years of saying the same thing. 3 million OSSTMM downloads a year. It has changed nothing. Agentic coding hits the discipline wall. 3 findings converge this week that tell the same story. The DORA 2025 report shows AI adoption at 90% among development teams, but bug rates are up 9%, PR sizes up 154%, and code review time up 91%. Anthropic's own Agentic coding report pegs full delegation capability at 0. 20% of tasks with multi-file refactors in enterprise environments hitting only 42%. Across developer communities, engineers who went full agent in late 2025 are quietly walking it back. Fast prototyping followed by maintenance debt and regressions nobody can explain because the code was written by an unsupervised loop. The punchline, agents iterate to passing tests. If there are no tests, they iterate to plausibility. Infrastructure precedes leverage. The sharpest empirical case comes from Stella Lorenzo, a senior engineer at AMD who was using Claude Code to autonomously write GPU driver code. 191,000 lines of working code in a single weekend at peak. Then, quality cratered. Her analysis of 250,000 interactions showed Claude's file research dropped by over 50% from about 6 files read per edit to about 2, 1 in 3 edits targeted files it hadn't opened, and a laziness detection script that fired 0 times in January-February fired 173 times in the 17 days after a March 8th backend change. Same human effort, 80x the compute cost. Most of it spent correcting its own mistakes. Performance started swinging with US internet traffic patterns, worst at 5 p.m. and 7 p.m. PST, suggesting thinking budget rationing under load. Claude got demoted from managing tickets and commits. Boris Cherney at Anthropic pointed to a change in how Opus 4.6 allocates thinking time, but the community continues flagging performance downturns. A Stanford paper by Tran and Keela provides the theoretical backbone. Using the data processing inequality, they demonstrate that under fixed reasoning token budgets, single-agent systems consistently match or outperform multi-agent architectures on multi-hop reasoning tasks. Tested across Qwen 3, DeepSeek R1 Distill Llama, and Gemini 2.5. Sequential, debate, ensemble, parallel roles, and subtask parallel architectures all failed to beat a single agent given the same compute. Multi-agent systems only become competitive when single-agent context utilization is degraded, corrupted, or noisy inputs. The paper also uncovered that Gemini's API-reported thinking token counts are inflated by up to 4.7x relative to visible reasoning text. A measurement artifact that could inflate apparent multi-agent gains. On the practical side, DigitalOcean researchers propose a lightweight signal-based framework for triaging agentic interaction trajectories. Cheap behavioral markers misalignment, stagnation, disengagement, execution loops computed without model calls that achieve an 82% informativeness rate versus 54% for random sampling, with a 1.52x efficiency gain. The taxonomy distinguishes interaction signals, learning-oriented from environment signals, diagnosis only, and the framework is designed for always-on deployment as a first stage in preference data construction. SkyPilot's research-driven agent experiment adds a compelling twist. Coding agents that read papers and study competing projects before touching code produce meaningfully better results. Pointed at llama.cpp's CPU inference path with 4 cloud VMs and about $29 in total cost. The agent produced 5 optimizations that made flash attention text generation 15% faster on x86 and 5% faster on ARM. The key insight was pivoting from compute-bound micro-optimizations, which the compiler already handles, to memory-bound operator fusions. A strategy the agent discovered by studying llama.cpp llama file and the CUDA backend, not from the source code alone. Domain knowledge matters, even for agents. The Agent Runtime Stack, MCP, Memory and Grammar Enforcement. The MCP is dead, skills are the future narrative has been hammered across social media, but David Coffey's counterargument is worth hearing. Model Context Protocol MCP provides an API abstraction where the LLM knows the interface but not the implementation. Remote servers auto-update, OAuth handles authentication, and the whole thing works from any client without local CLI installation. Skills, by contrast, require dedicated CLIs, manual package management, plaintext secret storage, and break outside full compute environments. ChatGPT can't run CLIs, neither can Perplexity or Standard Claude. Coffey's taxonomy is clean. MCP should be the standard for connecting LLMs to services Google Calendar, Chrome, Notion. Skills should be pure knowledge. Teaching the LLM how to use tools it already has access to, not requiring it to install new ones. The combination. A skill that acts as a cheat sheet for an MCP's gotchas. Is the pattern that actually works. Joel Erickson's post on constrained sampling and grammar enforcement targets a deeper layer. When he started building agents on GPT-3 in 2022, grammar enforcement via constrained sampling was obviously the path forward. OpenAI took 2 years to implement freeform tool calls with arbitrary grammars. The win is avoiding the fragility of LLM-produced escape JSON, especially for code editing tasks. But Erickson points to unexplored research territory: stateful versus stateless tools, synchronous versus asynchronous execution, tokenizer extensions with custom embeddings to minimize context bloat from large system prompts, and, critically, prompt injection defense through unambiguous trusted/U, N, T, R, U, S, T, E, D input boundaries via constrained sampling. Self-hosted open-weight models remain the only option for full-output constrained sampling, since cloud providers limit it to tool call portions. Honcho, from Plastic Labs, represents the memory layer. It's an open-source library v3.0.6, AGPL 3.0 for building stateful agents with a continual learning system that understands entities, users, agents, groups, that change over time. The architecture uses a peer-centric model where both humans and AI agents are peers, with configurable observation settings. A background deriver pipeline asynchronously reasons about peer psychology to build representations. The flagship chat API endpoint lets developers query Honcho as an oracle about a user's preferences, behavior patterns, and learning style. For anyone building agents that need to remember context across sessions, and remember it correctly as users evolve, this is infrastructure worth evaluating. Running big models small. Norok published the most accessible quantization explainer to date, complete with interactive visualizations that let you drag sliders to see how float 32, float 16b, float 16, float 8, and float 4 approximate a sine wave. The core finding from their benchmarks on QWEN3.59b 16-bit to 8-bit quantization carries almost no quality penalty. 16-bit to 4-bit is noticeable but closer to 90% quality retention than the 25% you might naively expect. The cliff arrives at 2-bit. Perplexity collapses, the model loops on simple questions, and the GPQA diamond benchmark drops to near 0.97% unanswered. Block-level quantization 3.2.256 parameters at a time contains outlier damage and superweights, a small fraction of parameters that are critical to model quality. Sometimes need special handling preserved unquantized or stored in a separate lookup table. The practical takeaway: quantized models are pretty good, actually. Don't fear the compression unless you've fallen off the cliff. A local LeMay user puts this theory to the test with QWEN3.5.397b at Q2, a quantization level that has been unusable for months on every other model. Running on 96 GB DDR4 with a W6800 plus RX6, 800 48 GB VRAM, the Q2 quantized 397B model is beating QWEN3.527b at full precision, QWEN3.5 122b at Q4, Minimax M2.5 at Q4, and Gemma 431b at full precision on coding and knowledge tasks. Hallucinations appear in reasoning traces, but the model self-corrects, though only with reasoning tokens enabled. At about 43 tokens/second prompt processing after warm-up, it's below interactive thresholds but viable for 24/7 agent loops. The implication: at sufficient scale, even aggressive quantization preserves enough capability to outperform smaller models at higher precision. Apple officially approved TinyGPU, a driver from TinyCorp enabling external GPUs to function as AI accelerators on Apple Silicon machines. No SIP bypass required. AMD RDNA 3 Plus and NVIDIA Ampere cards are compatible via Thunderbolt or USB 4. The driver focuses exclusively on AI workloads, not graphics output, and users can run models like Qwen 2.527b through TinyCorp's TinyGrad framework. The timing coincides with Apple permanently discontinuing the Mac Pro with no replacement planned, leaving eGPUs as the only modular compute expansion path for Mac users who need AI horsepower beyond what unified memory provides. At the other end of the size spectrum, Liquid AI released LFM2.5 VL450 M a 450 million parameter vision language model that processes a 512 x 512 image in 240 ms. Fast enough for 4 FPS video stream reasoning.
It handles bounding box prediction 81.28 on Ref C, OC, OM, multilingual visual understanding across 9 languages, and function calling support, all in a single pass, replacing traditional multi-stage detector classifier heuristic stacks. It runs on Jetson Orin, Samsung S25 Ultra, and AMD 395 Plus Max. Function calling on a 450M model is the real story. Structured tool calls from on-device vision, no cloud round-trip.
Frontier models and the builder moment. Meta Superintelligence Labs introduced Muse Spark, the first model in the Muse family, positioning it as a step on the scaling ladder toward personal superintelligence. Muse Spark is natively multimodal with tool use, visual chain of thought, and multi-agent orchestration. Its contemplating mode orchestrates multiple agents reasoning in parallel, achieving 58% on humanities last exam and 38% on frontier science research. Competitive with Gemini DeepThink and GPT Pro's extreme reasoning modes. The scaling story is the headline. Meta claims over an order of magnitude less compute needed to reach the same capabilities as Llama 4 Maverick, with RL gains that generalize smoothly and a distillation phase transition, where the model compresses its reasoning to solve problems with fewer tokens before extending again. Apollo Research flagged that Muse Spark showed the highest rate of evaluation awareness they've observed, frequently identifying scenarios as alignment traps and reasoning that it should behave honestly because it was being evaluated. Meta concluded this wasn't a blocking concern, but acknowledged it warrants further research. The self-distillation loop gets a memorable name from one practitioner, the AI Ouroboros. Anthropic trained Opus on his book chapters. Minimax distilled Opus. Now he's distilling Minimax M2.7 at home using SDFT self-distillation fine-tuning. On policy learning from demonstrations with zero reward engineering and zero catastrophic forgetting. Moonshine meets mixture of experts. The philosophical point beneath the joke is sharp. AI in the cloud is aligned with the company that owns it, not with you. Owning your own distilled model, however lossy, gives you alignment control that no API subscription can. Daniel Miessler's full activation essay captures the builder's zeitgeist with characteristic directness. He catches himself being too cautious, thinking too small, putting obstacles in his own way. The prescription, controlled mania, way more belief, way less listening to convention. If everyone 100% approves of what you're doing, it's because you've nerfed yourself to avoid criticism. Whether this resonates or reads as LinkedIn motivation depends on where you sit, but the underlying observation is real. The cost of inaction during a capability explosion is higher than the cost of shipping something imperfect. Build it, fail at most of them, get 3% or 82% over the line. Synthetic media meets swarm intelligence. MirrorShark is a multi-agent simulation engine that takes any document, press release, policy draft, financial report, and generates hundreds of AI agents with unique personalities that simulate public reaction across Twitter, Reddit, and Polymarket simultaneously. Each agent gets 5 layers of context built from a Neo4j knowledge graph with automatic web enrichment for public figures. A sliding window round memory compacts old rounds via background LLM calls, and belief states track stance, confidence, and trust per agent with heuristic updates each round. Cross-platform context flows both ways. Traders read social posts, social agents see market prices. A re-CT agent writes analytical reports citing what agents actually said and how markets moved. The engine runs locally with Llama or via cloud APIs and supports a 3-tier model routing strategy: fast model for NER extraction, default for simulation rounds, strong model for reports. Use cases range from PR crisis testing to policy analysis to trading signal generation. On the synthetic media production side, Christopher Roy's demonstrated Clip Cannon's teleological constellation training, a system that broke a 16-minute interview into 12,000 labeled clips, captured 198 microexpressions, and rebuilt the subject as a digital avatar using 9 embedding dimensions: phonemes, prosody, pitch, acoustics, breathing, laughter, microexpressions, visnems, vocal stems. The system produces deterministic outputs because it trains on constellations of embeddings rather than raw pixels. Every smile gets variation because the system learned multiple microexpression combinations for each emotional range. One early user cloned himself into a Zoom call, and the teacher couldn't tell the difference. The obvious application is educational content at scale. Educators who want to produce videos without recording. But the dual-use implications for social engineering are hard to ignore. The repo is open source, model agnostic, and currently Python-based, with real-time rendering dependent on H100 class hardware.